on thermal regulation and habitat use of the eastern box turtle. So what we did was each of the turtles, Dr. Fredericksen has 32 acres of property. So he found 11 turtles, 7 male, 3 female, and a juvenile, which means that it's so young you can't tell yet. And we attached radio transmitters and microclimate buttons on them. And you can see here, that's the button. And so what you do is you have this thing called a radio telemeter. And like here, basically it's a huge antenna like you would put on your house to get like old-fashioned satellite. And it's attached to a box, and you plug in the frequency of the tractor on the turtle, and then you follow the noise it makes, and it'll get louder and like higher up in pitch as you get closer. And then you find it, we record where it is, and what we're looking for is, has it moved from where it was last time? Why has it moved from last time? Was it hotter? Did it rain? Did it get colder? Or if it's a female, is it mating season? Is it going to lay its clutch of eggs? And then once a week, what we do is we'll also take the computer out, and you attach this device just on top of the I button, and it downloads the temperature data. And then what you're going to compare that to is the temperature of the turtle's microclimate, which is literally just the area right around the turtle, compared to the ambient temperature of the forest or the air like in that day. But basically what we're looking for is, through all that data, can we figure out why do they do this? Why do they move? What makes them move? Eastern box turtles are natural to deciduous, like eastern deciduous forests, but they can be found anywhere through fields, directly like basking in the sun. And because they're reptiles, they're cold-blooded, so obviously they have to use the air temperature to regulate their body temperature. This here is a male turtle, and on its plastron, which is the bottom half of its shell, it has the indent right here. It's curved in, which means that it's a male. Whereas on the female, you see it's completely straight. Also, the male shell is more elongated and lower, whereas the female literally has like almost a box shell, like completely around. Also, the eyes on the male are going to be a lot brighter, or like a deeper red, whereas the female tends to have a more lighter brown color. We've also found that male and female turtles have different home ranges, and again, we're trying to figure out why is that. You can see here on the map, number 34, one that we've been tracking is a male, and he has a pretty tight home range, stays in the forest pretty much all the time. Well, turtle 135, which is a female, on the same day we tracked her, and she was in the forest as well. But throughout the whole time, she's traveled so much farther than the male. And we've noticed that in all the females, actually, they go all the way down here. And she goes all the way down here just to lay her eggs, and then comes all the way back up. And again, why is that? Well, as it gets hotter, the turtles don't want to overheat, so they go into more secluded, more shaded areas. So for July, most of the time they're in the forest, or there were, I believe it was 7 turtles were in the creek because it was just so hot for them that they had to go into the water. But you can see here they're only in the creek in July, which shows that it's the temperature that's making them do that. And again, that's what we're looking for, which is pretty good that our data answers our questions. Also, turtles do this thing where if they get hot or they need to cool down, they'll go into a position which is called form. And what that means is that they get sedentary, like under the leaf litter. Like you can see here, we had pulled the leaves back, but he was formed under. And what that does is that cools them down still, because even just the top layer of the soil is so much cooler. They're active almost all the time in May, and then June, you might be like, okay, well, why are they formed more in June than in July? Well, in June, this is the data for the last week of June. We had a huge heat spell, and whereas July, it hasn't been as hot as that last week. In the 32 acres, there's 8 different areas. There's the forest, the edge, the field, early successional, mid-successional, creek, gap, burned area, where the turtles have the choice to go. So these are just the relative humidity and temperature of each of the areas, and then we can see, okay, well, in July, they're in the forest almost all the time. Okay, well, it's a lot cooler in the forest than, say, the field, so we can see how the temperature affects where the turtles move. So throughout the whole thing, you know, we started out talking about how the turtles, we want to compare their temperature to the outside temperature, or the temperature, you know, of the forest where it's cooler, the field where it's hotter, and see, does it make sense that they go where they go. And what happens is during the night and early morning, when it's still really cool, their temperature is above the forest temperature, which tends to drop a lot, but still lower than the field. But then as it gets hot, they go into the forest temperature, and you can see it gets a lot cooler. And basically this graph completely sums up the project and shows, hey, we were looking to see how thermal regulation and habitat use, like how that works together, and well, I guess we kind of answered that by showing that temperature affects what they do, and soon if we do a lot more research, we should be able to predict where they're going. A big problem is that turtles cross the road trying to get from one habitat to another, and so because of that, that destroys like a lot of the species. So by saying that, what we can do is we can go into that one habitat and say, why are they leaving this habitat? Why are they crossing the road? And by doing that, we can figure out, okay, what can we do to revamp these habitats and make them more suitable?